This is the sequence and series mind map. It was made to understand better the topic by Andrea. In order to understand the topic, we need to have clear the definitions. A sequence is an ordered list of numbers that follow a particular pattern. The individual elements in the sequence are called terms. And on the other hand, a series is the value received when adding all the numbers in a sequence. This value is called sum. To begin, I'm going to explain the arithmetic sequence. An arithmetic sequence goes from one term to the next one by always adding or subtracting the same value. The formula used to find an nth term is un equals u1 plus n minus 1 times d. Un is the term you want to find, u1 is the first term, and d is the difference. Now we find an example on an arithmetic sequence. The sequence is the following: 1, 4, 7, 10, 13, 16. This means d is equal to 3 and u1 is equal to 1. To find the 20th term, use the formula and replace the values. In this case, the new formula will be u20 equals 1 plus 20 minus 1 times 3. So u20 will be equal to 58. In arithmetic sequences, it can be used the Gaussian addition, which is reverse, add, and divide. Moving on to the next topic, we find the arithmetic series. An arithmetic series is the sum of an arithmetic sequence. The formula used in this case is Sn equals n times u1 plus n by 2, where Sn is the sum of the number of terms you want to add. In this case, if we want to use the formula to find S20, we need to replace the values into the formula. So it will be the following: S20 is equal to 20 times 1 plus 58, which is the 20th term, by 2. If we plug these values on the calculator, the answer will be equal to 509. So this is the sum of the first 20 terms in the sequence. On the other side, we find the geometric sequence. A geometric sequence goes from one term to the next one by always multiplying or dividing by the same value. The formula used in geometric sequence is un equals u1 times r to the power of 1. In this case, un is the term we want to find, u1 is the first term, r is 2, which is the number you multiply or divide at 10 by to get to the next one. Now we find the example of a geometric sequence. The sequence is the following: 5, 10, 20, 40, 80, and so on. In this sequence, the ratio is 2 and the first term is 5. To find the 20th term, use the formula and replace the value. So in this case, the formula would be u20 is equal to 5 times 2 to the power of 20 minus 1. The answer in this case will be 2,621,440. Now we can see the geometric series. A geometric series is the sum of a geometric sequence. The formula used in this case is Sn is equal to u1 times 1 minus r to the power of n over 1 minus r. To find the sum of the first 5 terms, we need to use the formula and plug in the values. So it will be Sn is equal to 5 times 1 minus 2 to the power of 5. All of this over 1 minus 2. After plugging these values in the calculator, we can see that the answer is equal to 155. So that's the sum of the first 5 terms. We can see now the chess problem example, which is a geometric series. If a chessboard is going to have rice placed on every square, having 1 grain in the first one, 2 on the second, 4 on the third, and so on, doubling the number of grains on each of the following squares, how many grains of rice will be on the chessboard at the end? The sequence will be 1, 2, 4, 8, 16, 32, 64, and so on. To find the sum, use the formula previously stated. U1 will be equal to 1 and R the ratio equal to 2. In this case, after plugging the values on the calculator, the answer will be 1.84 times 10 to the power of 19, which is a really big number. The next topic I'm going to talk about is infinite geometric series. An infinite geometric series is a series that is geometric, and which common ratio is bigger than -1 and smaller than 1. The formula in this case is S infinity is equal to U1 over 1 minus R. An example of an infinite geometric series is the following: 3 plus 1 plus 1/3 plus 1 over 9 plus 1 over 27. U1 is equal to 3 and R, the ratio, is equal to 1/3. The sum of this infinite geometric series is 4.5. As you can see, R is smaller than 1. There are different types of infinities, and it is possible to count after infinity, and some infinities are bigger than others. The order is the following. Aleph 0 is the one that includes natural, rational, even, and odd numbers. Then it follows omega, what comes after an infinity of numbers. Then the power set of Aleph 0, then Aleph 1, Aleph omega, and so on. Now we're moving on to interests. There's simple interest and compound interest. Simple interest is a quick method of calculating the interest charge and a loan. Simple interest is determined by multiplying the daily interest rate by principal and by the number of days that elapse between payments. On the other hand, compound interest is the interest calculated on the initial principal and also on the accumulated interest of previous periods of a deposit or loan. Two important things to know in order to solve problems related to interest is the interest rate, written as a percentage, and the times a payment is made, that can be by months or annual. Now, what is E? The number E is an important mathematical constant that is the base of the natural logarithm. It is approximately equal to 2.71828 and is the limit of 1 plus 1 over n to the power of n as n approaches infinity. Another famous example would be the Hilbert's paradox of the ground movement. It can be understood by using Cantor's theory of transfinite numbers. The Hilbert's hotel is a thought experiment which illustrates a counterintuitive property of infinite sets. The Hilbert's hotel had infinity of rooms, and all of them were full. Each time a new guest arrived, all of the other guests moved one room from the one they were in. So the guests in room number 1 moved to number 2, number 2 to 3, and so on, so that room number 1 was always vacant. A company decided to send finite number of buses with finite number of people in them. Hilbert didn't know what to do with all of these people, so Cantor suggested to do the following thing. Simply ask everyone to move into the room whose number is twice the number of the room they are currently in. Now all the odd-numbered rooms are empty. Assign the first person in the first bus room number 1, the second person in the first bus room number 3, then the first person in the second bus room number 5, and carry on in the same manner, picking one person from each bus as you walk up and down past the row of buses, picking people from one more bus each time. The previous example was one of the methods used to explain this paradox. But there are other methods, such as the prime powers method, the prime factorization method, and the triangular number method. All of them having as purpose to explain this paradox that many people do not understand. Now to conclude, I'm going to explain who were Cantor and Gauss and why were they important. Cantor was a German mathematician. He invented set theory, which has become a fundamental theory in mathematics. Cantor established the importance of one-to-one correspondence between the members of two sets, defined infinite and well-ordered sets, and proved that the real numbers are more numerous than the natural numbers. On the other hand, Karl Gauss is considered to be the greatest German mathematician of the 19th century. His discoveries and writings influenced and left a lasting mark in the areas of number theory, astronomy, and physics. This was my sequence and series mind map. Thanks for watching.